Hello everyone. In my previous video, I showcased automating a free 5G core network implementation on a public cloud using the Terraform, which is an infrastructure as a code utility. So in this video, I'll talk more about the network automation on how can we automate the network configurations. There are several ways or methods to actually access the network devices such as SSH, netconf, restconf, just to name a few. So in this video, I'll utilize the Nornir Python automation framework, which utilizes lots of different plugins such as NAPM, NetMiko, Paramico, to name a few. As part of this demo, I'll start with the setup overview. Then we will walk through the Python environment and the code, and finally we will run through the code and build the network topology, and we'll test the end-to-end connectivity between the R1 and the R5. So as part of the environment, I built this BGP topology in the GNS3. So we have a router R1, R2 and R3 in autonomous system 65001. Then you have a router R4 and R6, which are playing the role of an ISP1 and ISP2. Then we have a router R5, which is playing a role of a server on an internet. We have an iBGP between R1, R2 and R3, and eBGP running between the R3, R4, R5 and R6. So final goal for this topology and the demo is to have the connectivity between the R1 and the R5. For the automation of this topology, I have created the Python virtual environment, which helps to isolate the dependency requirement for each environment. So let me pull my Visual Studio Code, which is my preferred IDE.
So let's see how this Nornir framework simplifies the network automation. So if we look into the Nornir framework, it utilizes several plugins. So here I am going to use for my demo the Nornir plugins and the utility plugins. And if we look into the Nornir's website, so here you can see this is an automation framework written in the Python to be used with Python. And this is a very basic example which is given. This allows us to actually get the basic information and the interface details out of the network devices. If we further look into the plugins, so this is the Nornir's plugin architecture. Here it provides a different connectivity plugins such as netconf, restconf, GNM. And if you look into the plugins list, so this is the extensive list which is currently supported by this framework, and users can add their own plugins. So this is something that can be registered and the plugins can be added. If you look into the Nornir NAPM plugin, so this is the GitHub page, their GitHub page, and here you can see that it utilizes the NAPM for the connectivity with the network devices. And then it has something called tasks. So tasks are nothing but the functions. So here, this plugin provides you a couple of different functions for the task, the NAPM CLI and NAPM configure, ping and the validate. So these are all the functions which are supported as part of this plugin. And if we further look into the NAPM website itself, it provides you further details on what all the devices are supported, the basic minimum version requirement, and the caveat which are actually one should know prior to using the plugins. So if you look into this for the Cisco iOS devices, minimum version requirement is 12.4 OTT release, and under the hood it actually uses a netmiko plugin. So this is the libraries which are actually used by the NAPM to implement all the functionalities which is provided by the task in this particular framework. So these are all the configuration types which are supported. So here you can see we can completely replace the configuration, or we can merge the configurations. Then we have couple of different options. We can actually roll back the configurations. So a couple of minutes back, we actually saw one of the basic example, which was given on the website, where it was utilizing facts and the interfaces to pull some of the information out of the devices. This is a matrix which actually provides comprehensive of what all things we can actually pull out of the configuration and respective to their own iOS, different implementations. So this is a few information. For example, here we can put the BGP neighbor detail or BGP information, BGP config, ARP tables, a lot of other information which are actually generally needed. So we will see that when we're actually going to run through our program. So let me put the Visual Studio. So here we are actually just first of all we are importing all these libraries. We can utilize these libraries in our configuration in our script. These are all the method or the functions what we're going to use here. If you look into this is a very basic function where we actually using the while loop, and then we are going to the match and case operation. We are actually here we are asking the input of the user, and then based on the input which is given, we are actually calling the task or the functions or the method, and we are executing those functions as per the user input. So if the user says provide an input of operation, so we will run through the routing protocol info function, which actually in turns actually run through this task, where it run through the NAPM get and get all the information related to BGP neighbors and the interface IP. If the user input has a config, then we will run through the task of BGP config. Here, as part of the BGP config, the configuration, we are going to run through the basic NAPM CLI first of all. It will set the terminal NAPM, and then the NAPM configure, where we will provide this configuration file with the task name. So how is going to pull this variable information? We will talk about this when we are going through each and every YAML file, which is the requirement for this the Nornir framework. Similarly, for the other inputs, the delete, rollback, we are going to run through the respective task or the functions which are actually what we have configured. And if the input is exit, then we are just going to exit this program. And in case of the another input, we are going to ask the user to provide the correct input. This is a very basic the program or script. We are going to run through the different input and execute respective function. Now, if you look into the host.yaml files, here we have all the information for the respective host for the router 1, router 2, router 3, the SP1, router 4, router 5, 6. Here we have provided the host name or the IP information and port. And if you want to add something extra which is actually utilized by the NAPM we can provide as an optional argument. Here we can provide the others as well. That we can use these inputs to actually more logical operations as part of our. So the schema for this, we can actually get the schema for the host default and these configuration files. We can get the schema out from this JSON tab. Here we can run through this environment, then we can get this schema, and then based on the schema, we can actually build these YAML file and other group and the default YAML. As part of the group.yaml, here we have just simply given which platform we are using. So in our case, we are going to use iOS platform. And then here we have the default, we have given the user. So ideally, you will see the password is generally not given. So we generally run through the passwordless implementation, where we can simply use the certificate and utilize the certificate to actually log into the device. But in our this particular demo, we are actually here you have the basic Nornir YAML file. So the important thing here actually we are providing the path for the host file, and another important thing here is the threads. This is the total number of workers which will be running simultaneously. Here, the good thing about the Nornir is actually using the thread architecture, where actually it run through all the hosts at the same time, actually considerably reduce the time of the implementation. This is one of the way actually why the Nornir is used by, because a lot of programmers or where the implementation time is reduced significantly using the threads. So here you can increase the thread based on the number of devices as well, and how many systems the CPU and the workloads. And looking into our Python script. So this is just a basic overview. Here, if you look into the configuration files, here we have the config, where we are given the respective configuration for each and every router. Look into the is nothing sensitive. We have just given the basic configuration which we can uh, push to these devices. Here you can see the router 2 configuration, and respectively we have given this is the very basic BGP configuration. Here we are just configuring some of the basic route, and then we are using those route map to advertise the local preference and advertise the metric to the next routers, and changing the metric or the MED of the BGP or the neighboring routers. And then here we have the ISP1 configuration and ISP2 configuration. We are simply configuring the interfaces in the BGP on each and every router. Similarly, if we are going to delete the configuration, we can either use the rollback feature, which is doesn't require basically use the state of the previous configuration, or we can use the delete operation where we can actually simply remove the configuration. So here actually we are simply removing the BGP configuration and we remove the interfaces. And this is a very basic scripts where we are simply removing the BGP and then the respective interfaces. That's about the configurations. Now let's jump into it. Let's start the implementation. So now look into the libraries what we have installed here. So we can just simply run through the pip3 and it will give you a list of all the libraries installed. As part of the demo, I have installed this Nornir Framework. In turn, actually installed all the dependencies. So install this netmiko, napam, and the other libraries, which was required as per the requirement of napam library. To install the library, we can simply give the pip3 install and the library name, and that's how we can install. Similarly, as I mentioned, actually I'm using the Python virtual environment. So we can simply, if we want to deactivate, come out of this virtual environment, we can simply do the deactivate. Now you see the prompt has changed. So I was using Python 11 as part of this virtual environment. So if I want to log into my virtual environment, this Python virtual environment, I can simply then scripts and deactivate. So now you can see the prompt has have the now again login virtual environment of now let's these are all the files which I have configured here, which I have part of the BGP demo. So let me log into the BGP demo. So these are all the files that we have as part of the demo. Let me run through the code, and so these are all the options which being provided by this script. And here you can see the it's asking the input either the operation, config, delete, or rollback, or the exit. So let's say if you provide something which are not as part of the option, it will ask you to provide the input again. So let's provide the operation. So what it will do, it will just take this input and put it into lowercase, match it against the input what we have configured in the case. So just making it in the lowercase the string, and then actually matching it against the operations. And then it will run through the routing protocol info function. That's what really happens here. So now you can see currently, so it executed this task against each and every router. You have the internet one, ISP1, ISP2, router 1, router 2, and router 3. None of them any of the configuration in place at the moment. So you can see the BGP neighbor. This is actually provided as a dictionary, and this is completely empty. So there is no BGP neighbor relationship. The interface we have currently is only a single interface, which we are using to connect to these routers. this is actually the host IP which we have configured for the router to, so we can utilize the script to actually access to these routers and perform the required operation. So you can see in each and every router there is simply no configuration, no BGP neighbor relationship, or there is a physical interface. So now let's try to perform some operation. Let's try to do the config. So let's wait for the operation to get completed. Meanwhile, we can actually look into the console. So here you can see, so the script has logging in, and you can see it's configuring the loopback interface, required interface. You can see the neighbor relationship coming up. Here the configuration is in progress. So it appears the configuration is completed. So this is the configuration done for the R3. This is the configuration done for the R2. This is the configuration completed for the R1. Similarly, we can see the ISP2, ISP1, and the Internet IP. So you can see the configuration is completed for each and every router. And now if you perform the operation again, you will see the BGP peer, the neighbor relationship, and a lot more interface. So here you can see, for example, take the output of the router 3. Here you can see now the BGP, it has the BGP neighbor relationship. It has 3 pairs. One is router 2, where actually it's using the address family IPv4 unicast, and then actually the remote ID is to router 2. Then similarly, it has the neighbor relationship with the 4 and 6, which is our router 4 and 6 respectively. And these are all the interfaces which are actually taken up. So this is actually is providing in the dictionary where we can actually utilize these values for the further use. Now, if you look into our console, here, as we mentioned, the router 5, here it has the neighbor relationship. And now if you look into the route table, here it has the all the routes. So let's see. Now let's try to ping this. Now we can ping the router 5. It took some time, but I think the router also has this BGP. Now let's try to ping the router 1. So now we have a complete neighbor relationship, and we have the complete connectivity between router 1 and the router 5. We're actually going through the iBGP neighbors and then actually if you look into our topology. So this was the router R1 and this is the router R5. So he's actually going to this the iBGP neighbor relationship and actually utilizing one of the route to actually reach to the R5. So in our case, we have one route which is 100 Mbps and another route with 100 Mbps. So we are actually giving the metric to utilize the preferred path, which is the other router 6. Similarly, we can use the BGP as path prepending as well to actually change the preference towards the peer routers. So we can use the either method to actually we can use one of the BGP path attribute. We can utilize the preferences, and we can change the preferences that which path to be used. Now let's try to delete all the configuration here. Now let's check the console again. So what we'll do, it will just log into this router again and then run through the configuration to remove the configuration interface. BGP relationship is shutting down. I will look into the console. So here you can see the configuration being created for the router 3, router 2, and the router 1 and the other router. ISP1. And now if you look into the operation again, so we should be able to see that there is no BGP peer relationship, or there should be single interface again. Now we can see again all the BGP peer neighbor relationship is gone, and there is a single interface which was the state at the beginning of our at that time. This actually conclude this demo. In future, we are going to add a bit more functionality where so currently we don't have any error handling in this script. So the next demo, we are going to add the error handling using the try and accept. Then we are going to add a bit more functionality, and we will see how the different input what we are receiving as part of operation, where we actually getting all this information for the BGP neighbor interfaces, or we can get information for that. How we actually utilize those specific information out of this output we are receiving as part of this. We will see how to generate the reports. So we are going to add a bit more functionality in the next step. So thank you very much for taking the time to look into this. I look forward